In part 2 of the Pi Event Frames video, we'll demonstrate how to dynamically change the tags used for reporting over the event frames. The first scenario we'll look at is where a batch or process could be run on different pieces of equipment, but where the process is identical. For example, a batch could be run on any one of 5 identical bioreactors, depending on which was available. Or in a heat treatment process, parts could be processed in one of several heat treat furnaces. The two key features we'll use to accomplish this are the use of data models to organize the tags used in each piece of equipment, and virtual report instances, or VRIs, for identical instances of the same report that only differ in the tag names that are used in each instance. To simplify the relationship between the data models and the virtual report instances used, we'll make the data model names identical to the virtual report instance names. I'll start by creating data models for each line or piece of equipment with tags from the appropriate data source. The key here is that if the tag names are not identical for each equipment, we can rename or alias them so that we can have a consistent tag naming scheme for each data source. Here I've already created 2 data models named Line 1 and Line 2 from my Pi Asset Framework tags. I'm going to add a third data model for Line 3, select the tags, and then alias them or rename them to match the others. We'll come back to the data models shortly. Next, we're going to configure a few clusters, which will be used to display content in sections of the batch report. Looking at the finished report, for the batch and phases summary, I want 2 main clusters. One to show the overall top-level batch information, and then another cluster to summarize the phases that were run, as reported by the event frames. Here I have the top-level cluster, which I've named EF Batch for Event Frames Batch, very similar to what we created in the first Event Frames example report. This simply shows the batch ID, the start and end times, and the recipe parameter that was exposed from the event frame. I have these as expression objects in a simple free-form table. For the batch or phase ID, recall from part 1 of this video that I used that special system dynamic token. The recipe parameter was exposed in the batch definition. For the start and end times, I'm using system dynamic tokens for batch start and batch end. But I could simply have used the standard Dream Report functions for batch start and batch end, as I did in the earlier example. I just wanted to show that you have both options available. We don't have to set the time period to be batch-based, as that will be automatically assigned when the report generates. We'll set that later in the batch objects. The next cluster we'll look at is named Batch Summary, although maybe Phase Summary would have been a better name for it. Again, we place a grid with a set of expression objects on it, which will show the phase name, start, end, and duration for each phase. When the report generates, this cluster will automatically be repeated for each phase or event frame that ran. Now we're ready to place these 2 clusters on a new batch report. I'll start off by applying the same template to give my reports a consistent look and feel. And just as we showed in part 1 of the Event Frames video, we'll add a batch object to the report. Select our coder batch definition, and then for the top-level batch, we'll associate the EF batch cluster we just showed. For the coder phase level, associate the batch summary cluster. Finally, for this batch object, we need to define the time period to be batch-based and select the coder batch definition. As a reminder of what this batch object will render when generating the reports, we see the top EF batch cluster with the overall batch summary information, and then the batch summary cluster being repeated, summarizing each phase that ran for this batch. Now what we want to do is create a new cluster that will be used to show the actual process data that was recorded during each of these phases or event frames. Remember, this batch could run on multiple pieces of equipment, which we'll report on using virtual report instances, so we'll name this cluster Instance Cluster, just so that we can easily identify it for the purposes of this video. I've already configured a few reporting objects on my Scratchpad report, showing the process data, so I'll paste them onto this new cluster. At the top of the cluster, I've put a data grid showing the same phase summary as I had on the batch summary cluster, and the other objects show actual process data as summary tables and trends. You'll notice all the tags I've used are from the Line 1 data model or data source, but the data source will be dynamically replaced in the report instances. I now want to go back to our main batch report and create virtual report instances for each equipment or line in this case. As I mentioned earlier, we want to make the VRI names identical to the data model names. So I'll name these report instances line 1, line 2, and line 3. And just a quick review of how I named the data models. We need a way to figure out which report instance is generating so that we'll be able to assign the appropriate data models tags. To do that, I'll put an expression object on the main report with a function to get the instance name. We'll refer back to this later on. The last major task we need to do on the batch report is add the instance cluster and add a script to associate the appropriate data model with the report instance name. I'll add a new batch object to the report for the phase process details, and again select the COTA batch definition. We're not interested in showing anything here for the overall batch, so we won't associate a cluster at the top level. But we will associate the new instance cluster with a COTA phase from the batch definition. You'll see here that all reporter objects from that cluster are listed, which will then allow us to make tag substitutions in each object. You could double-click on each object name and then make one-to-one tag replacements. Here, for example, on the trend, we could select each tag and switch out the data source from line 1 to line 2, that is, leaving the tag names the same but changing the data source. And then repeat for all tags on all other objects on this cluster. What we rather want to do is have an automated data source change for all tags on the cluster when the report generates, based on which virtual instance is running. To do that, we click the Replace Script option and then open the script editor. I'll add a script template, which will get us started. The ODS data address correction function is used. This function returns an array of all the tags used in the cluster with any assignments you make in the script. Because it's an array of tags, you only call it once and Dream Report does the rest, sending back all the tags in the cluster. The three parameters that it accepts and then returns are the data source name, the item or tag name itself, and whether it's a value from an external history source, for example a PyHistorian, or a value that's logged in the Dream Report history. In our example, we're going to leave all the tag names the same, but only change the data source name, depending if the report instance name was line 1, line 2, etc. For the source name, using the getDataFromToken function, we're going to assign it to the expression object we created earlier, which contains the report instance name. And that's all we have to do. In the final part of this video, we'll show how to make any tag assignments in the script. For instance, if this phase is a mixing phase, assign some mixing tags. If it's a heating phase, assign different heating tags, etc. This is where the assignments would be made. Okay, let's remove those example lines and close the script. Finally, as we did before, set the time period to report on to be batch-based for our COTA batch definition, and then close this batch object definition. Note that there's nothing special to do on each virtual instance of the report. Everything is done on the main report template. I'd like these phase details to start in a new page, so I'll add a page to my report. And then cut and paste the phase details batch object to this page. We'll do some final formatting on the report, and we're ready to test it. Let's save and reload, and we'll open up the Runtime Management Console. I'm going to generate this report for the last batch that ran on lines 1 and 3. So select each instance and then generate. Normally these would be triggered automatically at the end of a batch. Once the reports generate, here we see two PDFs generated, one for line 1 and one for line 3. You'll notice that the batch header is the same because the same batch ran, but it's the process data in the phase details section that differs from line to line. As I page down through the PDFs, I'm seeing each phase that ran on each line, and the trends and summary data that are being reported from Pi are specific to each line. Notice the differences.